All right, you guys, here is a brand new topic that I'm pretty sure you guys have never seen before, but it's good because it's good to learn new things. Now, um, I would say this topic isn't that bad, but just takes a little while to just get used to it, but I have full faith that all of you guys can do it. And then always hop in my tutoring hours to you guys anytime you need help from 3 to 5 o'clock. Okay, so let's begin. So we are going to get into something you guys call complex numbers, and first we're going to start with this I, okay? So if you guys take a look at this I, this is what you call an imaginary unit, okay? It's represented as I. So there are such things, you guys, called imaginary units or numbers, and the ones you guys will get exposed to is imaginary numbers like this, where do you guys recall that you can never take a square root of a negative number? Well, now we're going to describe those as being an I. So a square root of -1, you guys, is equal to I, which is an imaginary number. It's a number that just does not exist. So in your guys' first Khan Academy assignment, it's going to give you these square roots, and you guys just have to simplify it. So let's begin. Now, do you guys see how this is square root of -25? Well, from above, we know that square root of -1 is equal to I, right? So if you guys split this up, we have plus or minus the square root of -1 times the square root of 25. So square root of -1, you guys, times the square root of 25. Well, we know the square root of -1 is I. So all we have to do is plus or minus I square root of 25. And then we can just simplify the square root like you usually do. Now, if you guys forgot, square root of 25, you guys, is simply just 5. So it's just going to be 5i. I'm actually going to reverse this so that I'm just going to put the I in the back of it so that you guys know. Okay, and that would be your answer. Now let's take a look at this one. Okay, example 2. Now remember, the I is at -1. So we're going to do plus or minus. Now we know the square root of -1, you guys, is I now. So let's just take out the -1 and just put it on the outside. I. Okay? Notice how there's no more negative sign. The negative sign, the square root of that negative sign just becomes the I on the outside. And then you guys just simplify this like usual. Now remember, with square roots, you have to do the prime factorization, right? And you guys just factor, and if you guys do not remember, all you have to do is just find your pairs. Well, do you guys see any pairs here? Yes, we do. We see a pair of 3's right there, and we see a pair of 2's right there. So remember, those get to come on the outside. So plus or minus 3 times 2, right? And then leftovers, you only have one leftover, which is right there. So that leftover must be on the inside of the square root. So then plus or minus 6 square root of 2i. Okay, over here, there's a negative sign on the inside of the radical. Remember, that's the same thing as radical -1 times radical 55, which means we can pull out that negative sign on the inside of the radical and just make it I. And then we simplify this. So 5 times 11. Now, do you guys see how 5 and 11 can't factor anymore? And then you can't find a pair, right? So if you can't find a pair, then that means this is as simplified as it can be, I. So there's some practice on that. Now we're going to get into this, okay? So you guys know that I, the imaginary number, is equal to square root of -1, okay? So here we have a list of powers, all right? So I'm going to erase this for now. and we'll talk about that later. Okay, so let's take a look at this. So we can just say I is equal to I, right? Now, if we took I to be to the second power, wouldn't we also have to take this side to be the second power? And then wouldn't I squared is equal to, well, square root and second power cancel, you guys, so that's just -1. So from that showing, we know that I squared is equal to -1, which is how we get this. Okay. So we know I squared is equal to -1. Now let's check out I to the third, right? Well, to get I to the third, wouldn't that just be I times I to the second? I times I to the second, you guys, that would give you I to the third. Well, what is I? I was just I, but what was I squared? I squared was just -1. So -1 times I, you guys, is -I, which is equal to I to the third. I'm just showing you guys the derivation, or how you get each and every single one of these. Okay, I to the fourth. Well, I to the fourth, well, we can use this one, right? I to the second times I to the second, which is equal to I to the fourth. Well, what is I to the second? -1. And the other I to the second is also -1. -1 times -1 is 1. So this is 1. And this, you guys, is your list of powers. So with these four, with those four, you can get any power of I. So, watch. If you guys have I to the fifth, right? Well, how do we get I to the fifth? Well, I to the fifth, using any of these, that would be I, right, to the first, times I to the fourth. We know I to the first, you guys, is just I, but what's I to the fourth? Times 1. So this is just going to be equal to I. So I to the fifth is just I. How would we get I to the sixth? Well, I to the sixth will be a combination of this one and this one, right? I squared times I to the fourth. But what is I squared times I to the fourth? I squared is -1. I to the fourth is 1. -1 times 1 is -1. I to the seventh, I to the third times I to the fourth, which is -I times 1, which is just -I. I think some of you are starting to see a pattern when we do these, right? I to the fourth, which is, not I to the fourth, I to the eighth, which is equal to I to the fourth times I to the fourth, which is just 1 times 1, which is just 1. So if we did another set, you guys, I think you guys can predict what the other set is. Now, just know that anytime you guys just do any type of I to the fourth, it's just always going to equal to 1. So if we did it any big number, we could get so with any I to any power, we can get the answer to, because it's always going to be a cycle of these four. I, -1, -I, and 1. So if we had I to the ninth, that would just be I to the 10th, -1, I to the 11th equals -I to the 12th, which is equal to 1. And in the examples, I'll show you the shortcut on how you get these. Okay, so let's look at example 1. So for example 1, you guys, this is kind of like the trick. You know I to the fourth is equal to 1, right? So how many times does 4 go into 8? Isn't it twice, right? 8 divided by 4 is 2. So since it goes evenly, all you have to focus on is the remainder. So watch. 8 divided by 4, it goes into 2 times with the remainder of 0, right? So this, you guys, is gonna be the power of your I, and that's how you guys kind of like simplify it. So I to the 0, anything to the 0 power is just 1. So this is just gonna equal to 1. Again, this is a shortcut. Otherwise, you guys would have to use these to go and find it. So watch this one, okay? I to the 41, you have to simplify this. So it would be, well, how many times does 4 go into 41? 4 goes into the 41 10 times. What's the remainder? 1. So the remainder is 1, so that's going to be the power of your I to the first. So that's just equal to I. So this is just equal to I. The reason why this works, you guys, is because 4 I to the first is 1. So if you want to know why this works, really, can't you just do I to the 4 times I to the 4 times I to the 4th times I to the 4th, 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 I to the 4th. That is 40 that's 40 i's in total times I. Well, you know, every single one of these is just going to be 1. So then all you're left with is just I. That's why this process works, you guys. So this is just going to equal to I. Alright, this one. Okay, how many times does 4 go into 82? 2, 0. 20 times with a remainder of 2. Right? Remainder of 2, so that means we're going to have I to the second, and I to the second, you guys, is just negative 1. So this is going to equal to negative 1. So there's 4. Now we're going to get into this part. So we are talking about real and imaginary. So here are some real numbers, you guys. These are actual values. 3, 2.6, 4/3 pi e square root of 2.3. Now, those are real numbers, right? So those are real numbers. And these are what you call imaginary numbers, okay? I, negative I, pi I, square root of negative 1, radical 27i. Those are imaginary, okay? Now, we're going to get into these things called complex numbers. So when we combined real numbers with imaginary, this whole thing is called complex numbers, okay? Complex numbers is real and imaginary together, okay? Well, they can also be apart, but this whole thing is a complex number. This right here is your imaginary part, and this right here, or sorry, this is your real value, and this part, that's the I, that's your imaginary value. And the sum of them both is a complex number. So when you guys look at your examples, they're going to give you examples like this. And they're strictly just going to be asking you guys which one is the real part of the complex number and which one's the imaginary part of the complex number. So the real for this one would just be your 6, and the imaginary for this one would just be negative 3. For this one, now this is the real, right? So that is the real number, so it's 80, and the imaginary number is negative 60. Okay, so that's just your introduction to parts of complex numbers. Now we're going to get into classify, okay? So again, this whole thing is the complex number, right? This right here is a real, and this right here is imaginary. But if you guys are looking at this, real and imaginary are subsets of a complex number, meaning if it's strictly just imaginary, that's a complex number. If it's only a real, that's also a complex number. So when we get into example 1, they're going to ask you, Is this real, imaginary, or complex number? Well, it's definitely a complex number because it consists of real and imaginary numbers, and that's it. Can't be real or imaginary because this is imaginary and this is real. Now let's look at 37.9. So first, this is definitely a real number, right? Because there's not an I attached to it. Now, it's also a complex number. Because remember, complex number could be a real strictly, or an imaginary number strictly, or it could be both. Okay, now when we look at example 3, example 3 is an imaginary number. It is not a real, but it is also a complex. Alright, now we're going to get into your last section of graphing. So again, this is a complex number, right? This is the real part of the complex number, and this is the imaginary part of the complex number. Now, you guys can graph this on a two-dimensional plane, but the axes are going to be different. What you guys know to be your x-axis, that is going to be your real, and what you guys know to be your imaginary your y-axis, that's going to be your imaginary. So, with this knowledge, you guys should be able to know how to graph this, and we'll look at some examples. Okay, so they're going to ask you guys to graph. So, here is your complex number, and it's going to tell you to graph it. Well, this one's your real, right? And this one's your imaginary. So if that's your real and imaginary, you guys, all you have to do is just graph this on the real and imaginary plane. So it's positive 3, so 1, 2, 3, and it's negative 2. So down 2 on the imaginary, 1, 2. So here's your guys' coordinate, 3, comma, negative 2. For this one, okay, so what is this? This is just a real, right? So all you have to do is plot 4 on the real imaginary, starting from 0, 0. 1, 2, 3, 4. There's your point. And example 3. Alright, 2i. This is imaginary, so that means we need to plot 2 on the imaginary plane. Well, on the real and imaginary plane. So start from 0, 0, 1, 2. There's your coordinate. Okay, so I'll be posting the Khan Academy videos with this, you guys, and if you have some questions, remember 3 to 5 is when I'll have my tutoring sessions every day, okay? Alright, good luck, you guys.